This is Chevy Equinox 2.4 liter Ecotec crank no start part 2. Last time this engine wouldn't start. It had fuel, it had spark, it had good timing, but it did not have good compression. It failed a compression test, and then it spectacularly failed a leak down test. And through some impressive mental gymnastics, I was able to convince myself that that was because of a bad cam phaser. We replaced the phaser, did the whole timing chain replacement routine, and the engine cranks, but it will not start. I guess the lesson from that video is that there's no one easier to fool than yourself. I am still convinced that this engine did not jump time and that the valves did not hit the pistons. So what could possibly happen to this engine to instantaneously cause a loss in compression? This is a leak down tester, also called a differential cylinder pressure tester. All it is a pressure regulator, air pressure regulator, and 2 gauges. This gauge shows the amount of pressure that is available. This gauge shows the actual pressure in the cylinder. And if there is no leakage in the cylinder, these 2 gauges should read the same. And you can see that they do not. Where's all the air going? It's going into the intake. Why didn't I see that the last time we did this test? Because I took out all the spark plugs. I should have taken them out one at a time. So this intake valve is slightly open. The pressure is just going from this cylinder through the intake and out this spark plug instead of going through the throttle body. That should be at or near top dead center compression. So that's 2 out of 3. Are we seeing a trend yet? Are we formulating a theory? What could make all 4 intake valves suddenly leak without the engine jumping time? Let's pull off the intake manifold. I don't think it's too horribly bad on this engine. I think that might be far enough. Well, it turns out if you hold your mouth just right, you can get that intake out without taking everything apart. You got to bend a few things out of the way, but not enough to hurt anything. So if we look down inside this intake port, do you see how nasty that is? Let's look at this one. This one's really nice. See all that crap built up on top of the valves? This is pretty typical for a GDI engine, gasoline direct injected. So normally the injector would be right about here, right about where my tip of my scope is. And a fuel-air mixture would go past the valve, and that fuel would clean the valve. In a GDI engine, the injector is down inside the cylinder, just like a diesel engine. And there's nothing to clean the valves. So what I think has happened here is my attempt to diagnose the no start has caused a different no start condition. And that carbon got stuck on the valve seat. Now those valves will not make a good seal. I might be able to jam something down in there, like one of these long Q-tips, with a little bit of solvent on it, maybe some brake cleaner, and just try to very gingerly clean that valve seat and then roll the thing over so the valves are sealed and see if the compression comes back. It probably won't work, but yeah, I don't know how well that's going to work. That's a pretty good proof of concept right there. We went from, I don't know, somewhere down around 30 to up around 150. Gauge leaks a little bit, so you can't entirely trust it, but it is significantly better. So yeah, all we got to do is clean those valves. I bought this super cheap portable abrasive blaster kit, and it is full of crushed walnut shells. I also 3D printed this adapter that will let me attach the shop vac, and then I stuck a piece of 12mm nylon air line over the blaster gun, and I can just stick this contraption down in the port, blast it, and hopefully not make a huge mess. Let's see what happens. Never done walnut shell valve cleaning before, so should be an adventure. Number 2 valves are closed. I'm going to start with that one. I did go through with a pick and just chip off some of the bigger chunks. Hopefully that helps. Fuel line up. Made that mistake once before. Okay, crank it, please. What? Crank the engine. Okay. I think it'll work. So it ended up being kind of equal parts walnut shell blasting and actually physically mechanically scraping off the crap with various picks, and I also soaked them for a bit with some brake clean. I have picked and scrubbed and blasted. I don't think those valves are going to get any cleaner. The compression it's not fantastic. I got 105, 130, 150, and 120. I would think anything above 100 would be enough to fire, but I don't know that for sure. GDI engines usually have pretty high compression. Personally, I'm looking forward to AI taking my job, because working on these modern cars it's not a whole lot of fun. But with the way things are going, looks to me like AI is going to take over my job as a YouTuber, and I'm going to be stuck working on these stupid cars. Okay. Close enough. Doesn't even try. I was making no progress with this compression issue, so I decided to take drastic measures. It's really not that bad. The problem is, I still don't know what the problem is. I see no evidence that the valves contacted the pistons. They really look pretty good. I set up a fixture and measured the runout of the face around 0.002 on most of the valves. That's about 50 microns. So it's not perfect, but this engine's got 100,000 miles on it. I think that's probably within the acceptable range. Take a look at Exhibit A. See that? That is carbon that's gotten smashed between the valve and the valve seat. This is your classic 3-angle valve grind. So there's a facet here, a facet here, and a facet here. This one is the sealing one. And it really looks pretty good. For a 100,000 mile engine, these valve seats I think look fantastic. Exhibit B would be on the valve itself. See all these little spots? That's that same carbon that got stuck between the valve and the seat. I would have thought for sure, with all the blasting and brake clean and scraping and brushing that I've done, that I would have gotten it all out of there. But that does not appear to be the case. There's another test we can do. I'm just going to put some Sharpie marker on the sealing surface of this valve. And I'm going to give that some time to dry so we don't skew the results. Stick that in like so. Attach our spinny thing. No, that's the wrong one. That's what I expected. The Sharpie mark is worn off all the way around. I see no reason why this valve shouldn't seal, other than the crap that's built up on the valve seat. That stuff right there. Anyway, that's my conclusion. Crud between the valves. Well, we never had a chance here, so I wasn't even going to mess with the exhaust valves. I didn't hear air leaking out through the exhaust, so I assumed they were okay, but that is certainly not the case. I think they're actually worse than the intake valves. So this thing must be burning a lot of oil, like a whole lot of oil. If it's burning that much oil, we're probably going to have to do something about that. That may be why we're in this situation to begin with. The intake valves cleaned up pretty nicely, but the exhaust valves were really pitted, way beyond what you could lap. But luckily my dad has a valve grinder. It's not really set up for these valves. The stems are too small, but he had some adapters and we were able to make it work. Had a little bit of run out on the face. It's not ideal, but it's definitely better than having that rough surface. I don't know who invented these tapered valve keepers, but they must have had a lot more patience than me. This is my dad's old school method for checking the valves. I'm filling up the cavity with a thin liquid, in this case I'm just using gasoline, and then just blowing compressed air into the intake and exhaust ports. And if you see bubbles, you have a leak. And in this case I ended up with a couple of exhaust valves that needed a little more lapping. I don't know what it is about these valves, but they do not hold suction, no matter what you do. We'll use an old school trick, a little bit of vacuum or fuel line in a cordless drill. Jam that over the valve stem. Let's not look any closer. That is good enough. We have the right to repair, but that doesn't mean they have to make it easy. So I wanted to get the actual service data from GM instead of just relying on what ALLDATA says. So to do that, first you need to block out at least 2 hours on your schedule, because this is quite a process. You're going to go to acdelcotds.com, and then you're either going to log in or create an account. And if you already have an account and try to log in, it's probably going to tell you that your password has expired and you need to reset it. You're going to go through the process and it's going to say, we emailed you a code to reset your password. It will never email you that code. So just go ahead and create a new account. And then the password is going to require uppercase letters, lowercase letters, numbers, special characters. But you absolutely cannot use any character that's not one of those 4. So don't even try it. It will just freak out and never let you create an account. Then you're going to get all the way down here to the GM service repair information. You're going to select a 3-day subscription for $22. You're going to add it to your cart. Then you're going to go through the entire purchase process and you're going to click on checkout and nothing's going to happen. You do that 3 or 4 more times. Nothing happens. No errors, no messages, no nothing. Nothing happens. So you call the technical support hotline, you wait on hold for about 45 minutes, you finally get somebody, and they say, oh yeah, we don't support Mozilla Firefox, use a different browser. So you cruise over here to Microsoft Edge, you go through the same process, you purchase your subscription, and then it's going to charge you for quantity 2 for no explicable reason. Apparently it remembered the subscription from the other browser, and it doubled it up. So then you're going to call technical support and wait on hold for about 45 minutes trying to get a refund for the subscription that you didn't want to buy. When all that is finally done, you'll have access to the actual GM service data for 3 days, as many vehicles as you want. Anyway, it's ridiculous across the board. I think Chrysler's probably the worst, or possibly Nissan. Anyway, it's possible, but it is not easy. I'm going to get some information and we're going to start putting this engine back together. There's actually 2 little rings here on the camshafts. This is where the oil comes in for the phasers. You're supposed to have these little scarf cuts, which I'm sure you can't see, at the top. So there's the one right there, and there's one right there. I've got the cams lined up pretty close, I think, to where they should be when we go to time it. So the exhaust cam notch is at about 7 o'clock, intake's at about 10 o'clock. So we're supposed to tighten these to, I think, 44 and then 89 inch-pounds, and then back them off and then tighten them again. So we'll do something close to that. This is the little roller follower for the high-pressure fuel pump. And then this cap goes over top. It's got a special pattern they want the anaerobic sealer squirted into. I think it's pretty close. I smeared it a little bit right there. Yeah, I better go fix that. That'll work. Well, it's not difficult to see that this thing was burning a lot of oil. So this is the oil control ring set right here. So there's 2 scrapers and a spacer. And I mean, they are just completely packed. So there's no way the oil was getting through that into the drain holes and back down where it was supposed to be. That's not going to work. 4 brand new pistons with brand new rings. The thing is, I don't really see a difference. Like, I can't see where they've made a design change from this piston to the new one. The oil control ring dimensions are the same. The drain hole location and dimensions looks to be the same. So I'm not sure what we're actually going to gain here, but this is what they say to do, so we're going to put them in. We're going to hope for the best. Would you believe I found another problem? And I'm starting to get the feeling that whatever happened was way more traumatic than what I was led to believe. All 4 wrist pin bushings have spun in the rods. They're turned in the rods. I've never seen that happen. I don't even know how it could happen. I mean, something had to get hot, maybe, and expand and allow them to... Maybe the wrist pins seat. Well, no, they all pressed out. I have no idea how that happened. I've never seen that before. On top of that, 3 of them are cracked, and 1 of them has a whole piece completely broken out. So they are not usable. They have to be replaced. I called the machine shop. They said, no big deal, just a wrist pin bushing. Then they called me back. No one makes wrist pin bushings for this engine. You cannot get them. You got to buy the whole rod, and it's only available from GM. They made something like 6 million of these engines, and there are currently 2 connecting rods in the entire country, and they're both at dealerships. There are none in the national parts network, and we need 4, so that's not going to help us. So I tried to buy some used connecting rods. I called 7 junkyards. 5 of them told me, we can't help you. 2 of them said, we might be able to help you. 1 was only open on Saturday. I had to remove the engine myself, and I had to buy a whole bottom end. The second junkyard, same deal, got to buy the whole bottom end. No guarantee on the parts, and it would take 2 weeks for them to pull the engine. So that's not going to help us. Luckily, I was able to find some used rods on eBay, and they just showed up. I think they're going to work just fine. So for now, that problem is solved. But don't worry, I found another problem, and it's even more diabolical. It just didn't seem right to me that the engine wouldn't even try to start. I mean, it never fired one time after I cleaned the valves and got the compression up over 100 psi on all 4 cylinders. And according to the specs, that should be enough for it to run. So I did some more digging on the P0017 code, the cam crank correlation code. And there's a service bulletin about the cam sensor reluctor wheels. So what you're supposed to do is rotate the camshaft, the intake camshaft, until the number 1 cylinder valves are fully open, which is right about there. So the top of this little ear should line up with the top machined surface of the head. And it's not perfect, but it's pretty close. I mean, it reasonably matches the picture in the service bulletin. Now let's look at the exhaust camshaft. Oh, you're supposed to rotate it until the number 4 valves are fully open, which would be right about there. This picture is a little harder to see, but the little ear, which is this little ear here, should be sticking pretty much straight up. And it is sticking pretty much straight down. As far as I can tell, that reluctor wheel is about 180 degrees off from where it should be. Yeah. So that's fun. Unlike the connecting rods, the camshaft was readily available, so that's pretty much lined up with the reluctor wheel. And if you look at the key, you can see that it's pretty close to 180 degrees out. I guess this reluctor wheel is just pressed on, and there's no key, there's no pin, there's nothing to hold it in position except for friction. And I don't know how or why, but that friction was not enough. Somehow it moved on the camshaft. I don't know if it got way too hot or if it was the rattling from that, those broken timing chain guides or from that bad lock pin in the phaser. Are we having fun yet? It's quite a corner I've backed myself into. I've never seen anything like this. I don't know how this happened. I'm still not even really sure what happened. It is a comedy of errors, and I'm stuck right in the middle of it. And unfortunately, there are no good options. I've got way too much time and money invested in this engine to give up. I mean, it's the embodiment of the sunk cost fallacy. We could throw in the towel and try to buy a used engine, but it's going to have all the same problems. These things all burned oil, and I'm sure it would need a timing chain. And they're surprisingly hard to find and pretty expensive, probably because they had so many problems. Reman engine, I don't even know if they're available. I do know they're very expensive, probably more than the whole car is worth. What can you do? We got to keep going. The only thing I've got going for me is it's my brother's car, and hopefully he won't sue me if it takes, 5 weeks and 30 times what I initially quoted to fix a no start. We'll fix it. I promise that, but I can't do it today. Thanks for watching. My hunch is either from the timing chain just being so loose or from that broken cam phaser or the bad lock pin that it got some kind of harmonic vibration, Tacoma Narrows bridge effect, and it moved that reluctor on the camshaft. I mean, that would be about my 13th wild theory that has turned out to not be true.
How much does a new engine cost?
$7,000 for a factory reman.
I think if you're gonna save this vehicle, that would be the best option at this point. I know that's not what you want to hear, or what anybody on the internet wants to hear, but
I'm ready for 5 gallons of gasoline and a couple of matches.
yeah, that's called insurance fraud. So
Good?
Yep.
Oh, that went far!
That was the furthest one yet. I don't know. Don't hit yourself in the head with it. Ready?
It's more dangerous if you're the shooter than the fire.
Yes. Yeah.
Backfire catapult.
Nothing wears out a dog like a garage sale. He is over it. But so are we.